sometimes you're going to know how confident you want to be and what that margin of error is, and you need to be able to find how many items you need to have in your sample in order to be within that certain range. So if you need to find the minimum sample size, then we need to figure out how to use that equation for margin of error to find that. Remember, the margin of error formula is E is equal to plus or minus the critical value, the z-score, times the standard deviation divided by the square root of n. Well, if we take that equation and try and solve this for n, the first thing we have to do is to times both sides by the square root of n. So I would have e square root of n is equal to plus or minus the z times the standard deviation. Now I need to get n by itself, so I'm going to divide both sides by e. So the square root of n is equal to plus or minus the critical value times the standard deviation divided by e. And finally, I need to get rid of the square root, so I need to square both sides of this. So n is always going to be equal to my critical value, z. The plus or minus goes away because when I square a positive, it's positive, and when I square a negative, it's positive. So it's going to be the critical value squared, sigma squared, and the e squared. So all of that squared. So using this formula, I can always find what my minimum sample size needs to be. Now remember, n is the number of things that need to be in your sample. So if n is not a whole number, then you need to round up to the nearest whole number. You always round up, you don't round down. If sigma is unknown, then you have to estimate it using S that's provided if you have at least 30 members in your thing. So you have to use the sample standard deviation if your sample has at least 30 members. Let's try this with this next example. The researcher in example 1 wants to estimate the mean number of hours spent on required athletic activities by all student athletes in the conference. How many student athletes must be included in the sample in order to be 95% confident and have the sample mean within 0.5 hours of the population mean? Okay, so our C level is 95%, and our margin of error is plus or minus 0.5. Okay, we know on this one that our standard deviation was 2.3. We know that because they gave us that before. And we know that for 95% confidence, remember we knew that our critical value for C was plus or minus 1.96. Okay, so from all those numbers, we can plug it into that formula that we just came up with. Remember, the formula is n is equal to the z critical number times sigma divided by e quantity squared. So n is equal to plus or minus 1.96 times sigma, which is 2.3, divided by plus or minus 0.5. All of that, it's squared. When we plug that all into our calculator, we're going to get 81.288, which we round up to the nearest whole number. So we need to have 82 is our minimum. Okay, we know that our sample from before had 40, so we need 42 more in our sample. Things that you have to take note of for this section, okay? Not if. Mu, our population mean, is a fixed number. It's either in the interval or not. Okay, so we can be somewhat confident that it's in the interval according to our calculations, but it's either going to be in there or not in there. It's not going to change based on what interval we come up with. Next. An incorrect statement. I'm going to write this out. If we say there is a 95% probability that the actual mean is in our interval, this is actually a incorrect statement. You can't make this kind of statement based on what we're finding using a confidence interval. Okay, the type of statement that you need to be making looks like this instead. If a large number of samples are collected and a confidence interval is created for each sample. Approximately 90%, or whatever confidence interval that we have, of these samples, or of these intervals, will contain the population mean. That's what a confidence interval does. That's the correct type of statement that you can make. Okay, you are being assigned page 317, 1 through 67, every other odd. So 1, then you skip 3, then you do 5, then you skip 7, then you do 9, and so on and so forth.